Today we're talking about tides. Tides are caused by the moon and to some extent the sun. Basically, we're talking about everyday rise and fall of sea level. Usually gentle motions, they have nothing to do with storms, they have nothing to do with regular waves. Although you can think of them as two waves that come in every day and go out every day. These three bodies contribute. The sun, moon, and earth have a relationship based on gravity. That relationship produces the tides. First, let's talk about the barycenter. Now, the barycenter can be thought of the center of mass. By the way, if this text looks familiar, I matched it with your textbook so that it would be easier for you when you're studying tides. But just so you know, the center of mass between two objects, such as the moon and the earth, would be called the barycenter. Just focus on the first bullet point. I got a little wordy when I was creating these slides. Now, if you're wondering where the barycenter would be, and you might be, go back one. Right here represents the barycenter between the moon and earth. Notice it's not in the middle of the earth. That means when the moon goes around the earth, the center of all that spinning is right here. You're probably wondering why it's not in the middle of the earth, and that's because the moon has a gravitational pull. It has mass. So the center of mass for the two systems is still in the earth, but a little closer to the moon. Okay. These black lines are called vectors. They basically demonstrate, shall we say, the direction of gravity and its strength. So this arrow is much longer. That means there's a strong gravitational pull on the side of the earth facing the moon. There's a little one on this side. Keep that in mind. And notice that all the vectors have a different length, demonstrating the strength of the gravity. Once again, I would not worry about these little details here. If you just know that the gravitational forces are represented by these vectors, you'll be fine. This slide demonstrates that as the Earth goes around the sun, takes a whole year, 365 days, sometimes it's really far away from the sun. Sometimes it's closer. It's never terribly close. We're still talking 93 million miles here, but that distance turns out to affect the tides as well because the sun has a little bit of an influence. By the way, if you're wondering when we're closest to the sun, it's not summer, as you might have guessed. It's winter, December 21st. Seasons are not caused by distance to the sun. They're caused by the tilt of the earth, and we'll get to that later. Okay, here's another vector, centripetal force. Maybe you've been on a ride at a carnival, a spin-out ride, where you're all stuck to the wall and the floor drops out after a little cylinder you're standing in is spinning. Basically, centripetal force is caused by spinning. Notice that every vector is the same length, unlike gravitational vectors. All the red arrows are the same length. Now, in physics, you're allowed to add vectors together. So, if I take the point of the red vector and make a line to the point of the black vector, I get these little blue lines. These blue lines are called resultant forces. There's a really nice description of these in your textbook, chapter 9. Now, notice that the blue is the same color as water. It represents water. What that means is this point right here, the water would be pulled towards the moon. It would be a hill of water. And any country spinning through that hill, because the earth continues to rotate on its axis, would rotate through a hill of water and experience high tide. There is always a second high tide bulge on the opposite side. So 2 places on the planet have high tide at the same time. This is caused by physics. It would look something like this. If you can imagine the ocean stretched out to exaggerate the tidal influence, this is what you would get right here. You would get a high tide here, a high tide here. So right now, West Africa would be getting a low tide, but as it rotated through high tide, it would go high, low, high, low, high, low. Turns out the moon is more important than the sun in causing tides. Even though the sun is much bigger, it's really far away. If Earth didn't have any land on it, if it just had water, there would be 2 equal high tides every day, 12 hours apart. But all that land tends to complicate things. The tidal range here shows where water level is at high tide twice a day, then it drops down to low tide twice a day. This demonstrates low tide. Low tide. In a lunar day, you have to add an hour for the moon to make a full rotation. So the Earth rotates on its axis every 24 hours. The moon takes 24 hours and an extra 50 minutes to rotate. And the result of that is, as the moon travels around the Earth, we only see one side of it. That's because it's also rotating while it's revolving. It's spinning on its own axis and it's revolving around the Earth. By this method, we only see one side of it. It always looks the same to us. The other side is called the dark side of the moon, and it's the best album ever recorded at Abbey Road Studios, in your professor's opinion. What is a tidal bulge? Well, it's a high tide area. The sun produces them, but we're not going to focus on these because they're not as exciting as the lunar bulges. As a result, twice a month, we have really high tides. That's because sometimes the moon and sun and earth line up. It's almost like they join forces. Actually, they are joining forces. And every new moon and every full moon, we have extreme tides called spring tides. They don't just happen in the spring. Spring here refers to the meaning of to rise up. Also twice a month, during the quarter moons, we have extra boring tides. You wouldn't even notice much difference between high tide and low tide if you were hanging out at the beach that day. These are called neap tides. Let's look at this a different way. In a spring tide, the moon and the sun line up and they combine gravitational forces. Right here, the neap tide, the moon is at a right angle to the sun. So they're not working together. They're sort of canceling each other out. So neap tides aren't very exciting. Now this is a pretty good figure. You'll find this one in your book as well, figure 9.12. It compares the moon's orbit around the Earth with the Earth's orbit around the sun. Both are elliptical. That means sometimes in the month, the moon is closer to the Earth. This is called perigee. It makes big tides. Sometimes it's farther. This is called apogee. It makes little tides. The sun and Earth also have these relationships. Perihelion Day in January is the day we are closest to the sun. This is commonly called winter solstice. We are farthest from the sun during summer solstice. What does all this produce? Well, there are three kinds of tidal patterns you can have. Each coast just has one. So some places in the planet only have one high tide every day and one low tide. Some have two high tides every day and two low tides, and they are pretty much the same in height. Places like California have two high tides and two low tides with different ranges. That means you can have a really extreme high tide in the morning, and in the afternoon, not so great, just a simple high tide. Sometimes you can see a wave in a river that's caused by the tide. These aren't going to be on the test, but they are pretty cool. So if you Google standing wave, you can see people surfing in the Amazon River. If you catch a real tidal wave, not a tsunami, but a tidal wave, you can surf it for half an hour. It'll go down the length of a river. This is a picture of a standing wave on a smaller version. It looks like they're never moving. Some places, like the Bay of Fundy in New Brunswick, Canada, have famous tides. Twice a day the water drops, and when it drops you can walk to this island. Twice a day the water rises, and you can't walk there. It's a tourist trap, but a pretty one. Here is a guy surfing a standing wave on the Amazon River. You can tell it's a river. The water is brown. It's probably a dangerous place to surf because there are logs and you could get hit with one. Also, things live in the Amazon that might eat you. So he's a very brave surfer. Right here is a historic photo of a standing wave in Alaska. And this happens twice a day. You can see this wall of water come down a river towards the ocean. Tides can cause features like whirlpools. They won't be on the test, but I want you to know they are real. They're pretty neat. Unlike Pirates of the Caribbean movies, though, they aren't that exciting. They're not going to eat your boat, spit you out. There are animals that have adapted their whole reproductive cycle to the tides. A little grunion, for example, we have these in California, will come way up onto the muddy beach during a spring tide, during a new moon, lay its eggs, then it goes back, the water goes back, and 2 weeks later the full moon comes back up, the water comes back up, it agitates the eggs, and they hatch. Now, over here where the fish are reproducing, that's something that you can go witness, and you're allowed to catch grunion and eat them. But the trick is you are not allowed to use a net. So it's slippery and it's hard to catch them, and it's pretty fun, especially if you have family visiting from another state, to do a grunion run. The Cabrillo Aquarium in San Pedro often leads tours of these, and they have a calendar for what night this is happening. Thanks for listening to Tides.